All right. So today we are going to find the segment VM. We look here, VM is where? Okay. What do we know, before we do our steps and reasons, what do we know about this graph here? Or this picture? What do we know? Cameron. Congruent? Okay, so we know this little mark here and this little mark here tells me that VM is congruent to MW. And what also are we given here? Do we know anything about VM? Yeah, it's 4x minus 1. And then MW is 3x plus 3. That's all the stuff that we were given. We are trying to find the length of VM. For this one, does it make sense for me to add these two up and equal the full segment? That's what we've done every single time so far. No. What makes sense for me to do over here to find the length? We talk about algebra. How can we find the length? Matthew, do you know?
Find x first.
How am I going to find x?
Because VM and MW are equal.
Mm-hmm.
We'll do that for an equation.
I'm going to make that into an equation. Okay. So let me go over here and say kind of exactly what Matthew said, but just in like steps. So he said because VM equals MW, how do we know that they equal each other? Because they're congruent. So this is the definition of congruence. So we know they equal each other because they're congruent. So then Matthew said, so we can do an equation for x minus 1 equals 3x plus 3. Because they were congruent, we can do that. What allows me to put in VM equals 4x minus 1? And what allows me to put in MW equals 3x plus 3? What allows me to put those in? Yell it out. Substitution. So now we're going to solve this equation. I like to start with the x's first. So I'm going to subtract 3x from both sides. It's going to give me x minus 1 equals 3. What allows me to subtract the same number from both sides? Subtraction. Property of equality. Subtraction. Subtraction property of equality. Now I need to add 1 to both sides, and I get x equals 4. What allows me to add 1 to both sides? Addition, property of equality. You will see that the more we do this, the more your teacher's going to get sick of writing the same word over and over again. So she's going to use accepted abbreviations. And if I use those abbreviations, so can you. Okay? If I use it, so can you. Don't make up your own, but if I use an abbreviation, so can you. All right, so we did what Matthew said. He said, find what x equals, and he said to do all this stuff. Is this what we were supposed to do? Rakaya, were we just supposed to find what x equals? What are we supposed to do? Okay, we're going to find the distance from V to M. So, VM, I know VM equals 4x minus 1, and we know x is 4, so I'm going to do 4 times 4 minus 1. What allows me to take out that x and put in that 4? Substitution. And then number 7, VM equals 15. How do I get that? Jay, do you know? What? Yeah. Do you know what the reason is? Do you know what I've been putting for those reasons? Okay. Simplify. Simplify. Yeah. So I'm asking you guys because I'm trying to gain, an idea of who knows what. I'm not trying to embarrass you or anything. I just if we don't remember stuff, you got to keep reinforcing. Okay? Let's pause the video, and I want you guys to try question B, because question B is almost the same as question A. All right? when you are done and the person next to you is done, or if you are stuck, I want you to say, hey, friend, you help me get this next step, or hey, friend, could we check our answers off with each other? See if we got the same answers. And you three are kind of a trio over here.
Can Ohio be my partner for today?
Or, yeah, you want to move over here. Actually, David, who do you want to be partners with? You move over here. And then we can still have a trio of dudes. Addition property equality. Yep, they're all, if you do something to one, like both sides of the equation, you do the same thing. It's always some sort of property of equality. Then whatever you did, that's what it is. Questions? I'm going to go over what I have. Are you looking at the number of steps you have? You guys look confused. Or do you have a totally different answer? Well, I haven't done it yet. That's the last one. I mean, I started it, but you can't. It like froze it, so you can't see it. Oh, that's neat. Okay, so I started mine. This is pretty much where you guys at least had gotten through. We say our givens, which is the congruence and what each segment was given. Then the next thing you do is say that PM equals MQ, definition of congruence. From here, we're going to set up the equation with substitution, and then I start solving it. So here's where our steps might differ a teeny bit. I added 2x to both sides, then I added 3, and I got 7x equals 14. I just called all of that the addition property of equality because I kind of did addition twice. You can write it as 2 separate steps and write addition property of equality, addition property of equality. That's fine. I called it the same step because I was doing the same thing. And then from there, I'm going to use the division property of equality, and I'm going to divide both sides by 7. So division prop of equal, and I get x equals 2. Once I have x equals 2, we'll plug it back in. I'll get, what am I trying to find? MQ. 11 minus, oops, let me write MQ equals 11 minus 2 times 2, just substitution. And then 7 would be MQ equals 7. Simplify. Or you guys, it might be step 8 for you if you did addition property of equality in 2 separate steps. Questions? Next one. Okay. What can we start with? Let's get some participation here. What can we start with? Should I just call on people? You guys feel confident?
Yeah.
Let's call on people. Jesse, what should I start with?
Okay. Well, to begin with, the RM and S, they are both congruent.
Okay. So I'm going to write those as segments with the congruent, meaning they have that line above it. And then what else?
Then you would put, for the second RM, it is 4x plus 3.
Okay, but I'm not going to write it as segment RM. I'm going to write it as distance or length of RM without the little symbol, right? Okay.
And then for NS is equal to 6x minus 12.
Perfect. And the reason?
Given.
Given. The easiest one. Remember, volunteer early. All right. Number 2. Alexa.
RM equals
MR equals what? What? MS, yes. RM equals MS. And Alexa, do you know the reason? Congruence. Definition of congruence. Emily, what do you think I should do next?
Substitute the RM and put 4x plus 3, and then do MS as 6x minus 4.
Okay, let me just tell you, I loved how you said right away, substitute the, so I already know what I'm going to write for my reason, substitution. Great job. Austin, what am I going to do next? Can you take your thing out of your ear, please, dear?
You do minus 4x both sides.
Okay, and go ahead. What's the reason?
Property of equality.
What kind of property?
Subtraction.
Subtraction, property of equality. David, what can I do next?
You add 12.
Mm-hmm. And what property is that?
The addition from equality. Yeah, addition from equality.
Yep. Addition, property of equality. Donovan, do you know what I do next? Like to get x by itself here? Well, 15 doesn't have x with it. 1, 2. So right now 2 is next to the x. That is what operation? 2x. Add, subtract, multiply, divide. What is it if it's 2x? Is there a subtraction sign? What's happening right here? Alex, what's happening right here next to the 2 and the x? What's operation? That's multiplication. So Donovan, what's opposite of multiplication? Division. So we're going to divide the 2 both sides. And I'm going to get x equals, you could have 15 halves, or you could have 7 and 1/2. Or you could have 7.5. That is the division property of equality. So we divided both sides. Okay. What segment are we trying to find? We know what x is. What segment are we trying to find? Cameron, what segment am I trying to find? What does it say in the directions? No. Right next to the C, what's it ask me to find here? RS. So I need to find from R all the way to the S. I don't have a formula for R all the way to the S somewhere written in here. I only have R to M and I only have M to S. Does anybody have an idea of maybe what we could do next? John?
We could substitute the x for 7.5.
Where?
For RM, it would equal 4 times 7.5 plus 3.
Just there?
And then MS would equal 6 times 7.5 minus 4.
Okay, we can do that. And I know you said the word, but what property is that? Substitution. Very good. So once we have that, by the way, I'm totally going to run out of space. So I'm going to have to like finish the rest of it over here. You probably are in the same boat I'm in. Until I can run out of space. So now I have RM equals, so gosh, did anybody do that yet? 15 halves times 4, that's 30. Plus 3, 33. MS, I hope that's the same answer. 6 times 15 halves, 45, minus 12, yep, 33. So that was simplify. I'm just going to move over here because I ran out of space. So how do I find RS? How do I find RS? Lynn, what should we do? Okay. Is there somewhere here that says that you find RS by doubling 30, like by doubling one of these? Is there something over here already established? Here's the hard part. This is the hard part about proofs. You can only really use stuff that's already up here, or accepted proofs, or accepted definitions, or postulates. So we actually have to say a postulate first before I can do that, Lynn. Cameron, do you know? Addition. Not addition property. It's a postulate. What kind of addition are we going to be doing? Lynn? Segment addition postulate. Yep. So that's the thing you hate the most about proofs, is because like you can totally find the answer, but can you put all the steps? Believe me, that's what I hate about them also. I mean, I don't hate you. I'm sorry to offend you. Okay, so I'm going to put RM plus MS equals RS. So now I have RS in here. I know how to find RS. So what can I do at this point? We've done this before. What can I do now that I have the segment addition postulate written down? What can I do? Substitute. Am I going to put all those X's and stuff in here? What am I going to put in here? 33 plus 33 equals RS. So that's substitution. So once I have that, I've got 66 equals RS. What did I just do? I simplified. And am I done? No, what do I need to do? Yeah. What is, it's not really flip, what is it called? Symmetric property of equality. Or symmetric. We'll just call it symmetric property. Symmetric prop. Oh, those 12 steps. That took half our class. Don't worry, there's only one like that in your assignment. There's only one. I'm sorry. We were supposed to have this last class, but then we played on our compasses so long. Okay. We have just correct? Oh, just making sure that I have the right thing in front of me because I didn't staple it together. All right, we just have one page left, and it is finding the midpoint and finding the distance of segments when we're given ordered pairs. We do not have to write steps and reasons for these. Okay. So these will go fast. This will be like the majority of your assignment. The majority of your assignment is this. I only gave you like one of these and one of these for your homework, for the proofs. Okay? So other than that, what we're going to do is we're going to do the midpoint formula. How do you find, let's say you have two grades in here. You have 100 and an 80%. How do you find your average? You add them up, you divide by 2. That one you might be able to like even logically think through without even doing the math. 100, 80, 90 would be your average right in the middle. But if you forget, what did she say? Oh, you were doing the, okay, yeah. So, what was I saying? Oh, but if you forget, we're just finding the average. If you ever want to find the middle of two numbers, you average them. So there's this formula that looks so crazy, like, oh my gosh, I'm never going to ever be able to memorize this formula, but you don't have to. If you know how to average numbers, you don't have to memorize a formula. So I'm going to go through this, but do it as we do the examples. Find the midpoint and the distance of segment RS. Here we have R and S coordinates, ordered pairs. So let's plot these. Remember, this is the x-axis, this is the y-axis. We're going to begin at 0, 0. Right 1 down 3 is R. I'm going to label it. And then right 4 up 2 is S. How convenient. You guys have straight edges there. And if you've ever run out of a straight edge, like you're out of my room, you could do that. You could use the side of your what's that thing? Planner, the schedule thing. Yeah, the planner. You could use a driver's license or student ID, your library card, any of the stuff that you carry around. You could use. Okay, we're gonna find the midpoint and the distance. I think you might even be able to find the midpoint by looking at it, but I'm just going to use the formulas. If we're trying to find the midpoint, then we're trying to find the middle of the x values and the middle of the y values. The middle of the x values and the middle of the y values. So we're going to average the x's and average the y's, and that gives us the middle. So what are my x's? 1 plus 4. Divide by 2. Remember, the x's come first. So 1 plus 4 divided by 2, that's 5 divided by 2. How about my y's? -3 plus 2 divided by 2, which is, I'll write it this way. Is 1 over 2. So 5 halves is the same thing as 2.5. If I go 2.5 and then I go, oh, I made a mistake because mine says it should be at 1/2. What mistake did I make? Because that's certainly not the midpoint. John, what mistake? It should be -1/2. See how I just caught my mistake by looking at the graph? So it actually should be down. And then we look at that and we say, yeah, that looks like I have the right answer. So that's my midpoint. We average our x's, we average our y's. Now the distance, has anybody heard of this? A squared plus b squared equals c squared. Has anybody heard of the Pythagorean theorem? 2 people have? Oh, thank goodness. A few more people have. I'm going to show you on the graph that we actually have a right triangle. And there is a distance formula sitting right up here that is Pythagorean theorem. It's just like in disguise right now. So I'm going to tell you right now, all you're doing is a squared plus b squared equals c squared, even though this looks super complicated. But I'll show you how that works. Look at our picture. If I were to measure from R to S, I cannot take R to S and count the blocks because they're not even spaced blocks that way. You can only count them when they're horizontal or vertical. So I would have to like count this way and count this way, making a right triangle. Do you see my right triangle? This would be like A, this would be like B, and then C is always the longest side. So I would do a squared plus b squared equals c squared. Now let's say we don't have a picture to look at and draw this. Or if you don't want to count how many blocks b is, then we can use this formula. This formula says to subtract the x's. So I'm using these points right here, and I'm going to subtract the x's. What's the difference between the x's? From 1 to 4, from 4 to 1, what's the difference? 3. I'll do that part in a second. Okay, I'm also going to subtract the y's. So I'm going to look at what's the difference between a -3 and a +2, or 2 minus -3. How far apart are they? They're 5 blocks, and you can see that and count on the graph also. So this is 3 and this is 5. So if we were going to do a squared plus b squared, what would I do to the 3 and the 5? Square them and add them. And then after you do 3 squared plus 5 squared, what would you have to do to find c when you're doing Pythagorean theorem? What would you have to do? You would have to square root. So this formula for distance up here is subtract the x's, subtract the y's, then square them, add them together, then square root. That's this formula right here. It just looks really confusing. But all I'm doing is Pythagorean theorem. So we're doing the square root of 9 plus 25, which is what? 34. Is 34 a perfect square? Okay, there was something in your weekly review where you're supposed to simplify it by breaking it down to a perfect square. And then everything else. Is there a perfect square that goes into 34? Examples. Does 4 divide into 34? No. Does 9 divide into 34? No. Does 16 divide into 34? Does 25 divide into 34? Does 36? Nope, that's already too big. So does 34 have any perfect squares that divide into it? Nope. So my answer, you can't simplify it. It's just square root 34. But what can we do? Doink. What can we do? John, have you got a calculator today? Oh, no. What can we do to find that answer? Okay, so if you do not know how to find the square root on your calculator, please pull it out and try it. Do you have a calculator? Do you have a calculator? Austin, do you have a calculator?
Nope.
Okay, do you have a calculator? Okay, so you notice I'm about to use it. We need to get those calculators and bring them next week. Square root 34 is approximately, so my approximate symbol is like a wavy equal sign, approximately 5.83. We'll do 2 decimal places. So when you do these answers, I want to see your square root and I want to see your approximated answer. I want to see both. And when I post your answer key, you're going to see all my steps and you'll see both answers too. Last example. The midpoint of JK is M21. One endpoint is 1, 4. And that's J. Find the coordinates of K, then find the length of JK. So we're looking here, let's see. M is the what? This is the midpoint. So here's J to M. Where in the graph, somewhere-ish, you don't have to tell me the numbers, but like where is K have to be? You might even have the answer, I don't know. 3, what'd you say? -2? Did you get that? Yeah? We know it has to be there. But what we need to do is we need to show algebraic work, so I'm going to show you that. Because what if the numbers were so big or so decimally that you couldn't just guess? But, oh, okay. your homework is up on the, right up there by the learn. It should say 1.3, like assignment. It's all the way on the left side. You see it? And it should just be one page, right? Okay. Is it one page? It's one page. Hold on, is it one page? Yes, it's just one page. Okay. All right, so, and then this will be posted. Lynn, this will be posted. Okay. So what we're going to do is we're going to say that if I average together J and K, I should get M. So if we average together J, the X value, plus the second X, if we average those together, this is the average of the X's, I should get my M value, which is 2. So I have an equation. I'm going to add together my first X and my second X, divide by 2, and I get the answer 2. How can we solve this equation for X? You want to take away like the outermost thing first. You want to get rid of the outermost thing first. Avneet? Right, if we multiply by 2, that's going to cancel out the dividing by 2. So you're undoing your operations. So I get 2 plus x2 equals 4. That would be the multiplication property of equality, just in case anybody wanted to know. What should we do now? Denise, what should I do now? Subtract 2. So I get x2 equals 2. So I averaged my x's. I solved for that other x. I got 2. And that's not right. Does anybody know what I messed up? I know what I messed up on now, but I know that's not right because I just looked at my answer. It should be 3. What did I do wrong? And you all let me do it. Okay? Yeah, I did. I looked at the wrong ordered pair. I looked at the M. I didn't look at the J. That should have been a 1. So that's going to change this to a 1. Did you see how I made a mistake? Because I'm not perfect. I know you all thought I was. I made a mistake, but then I looked at my graph and I was like, oh, I know I'm wrong. So now I went back to figure out what I made a mistake on. So it actually should be 3 for my x. Okay, let's do average the y's. So if I add together, this time I'm going to make sure I'm using the y from the j plus the second y I don't know divided by 2, I should get the y from the m. Aaron, what should I do both sides to solve this? Yep, multiply by 2. That's the exact same thing we just did on the first one, too. So you're undoing that, divide by 2. Stephen, what should I do? Right here. What operation is between the 4 and the... Subtract 4. So you get y2 equals negative 2. And isn't that what I needed to find when you look at my picture? So my answer for K is 3, negative 2, which we got from the picture. And you can totally get from the picture if you want. I just want to show you how to do it algebraic, just in case you can't get it from the picture. Okay, and then we have the distance formula really quickly. We have the distance formula. So you're going to have a square root to do. You have to subtract your x's. Then you have to square them. You have to subtract your y's. Then you have to square them. Add those together, square root the whole answer. This is the Pythagorean theorem. So we're going to do this from J to K. You can either subtract on the graph, or you can use the ordered pairs. So if K is 3 and J is 1, what's 3 minus 1? Okay. So we have 2 squared plus, Now we look at our y values. We've got a 4 and a minus 2. 4 minus negative 2 is 6. Or we could have counted on the graph 2 and 6. So we do our Pythagorean theorem, 2 squared plus 6 squared, and then square root that answer. 4 plus 36, which equals square root of 40. Okay, in your weekly review, you were supposed to simplify square root of 40. Is there a perfect square that divides, and we make a factor tree, into 40? Cameron. 4 is correct. 4 times what? Perfect. And then you say, what is the square root of 4? So 2, and then the square root of 10 you cannot take the square root of, so I bring it down to square root 10. So one of my answers is 2 square root 10. The other answer, if I do square root 40 or 2 square root 10, either way I type it in. Either if I type it in both ways, I can check them right. Is approximately 6.32. That's how long that segment is. Okay, I'm going to pass out your assignment. You guys will have the answers posted for you, and you have tons of time to do it. Tons of time. And I have tons of time to grade all your stuff this weekend because I was going to go to Florida. There's a hurricane coming, so I had to cancel everything. I literally have been looking forward to this for 6 months. I've been staying right on the beach on my favorite island, right by all the seashells, so I could wake up at 6 in the morning and look at the seashells. Oh, yeah, you don't go to Florida in the summer.
Really?
It's hot. But if you're at the beach, it's not that bad. But if it's 100-mile-an-hour winds, you probably shouldn't go, I guess. You might have tornadoes afterwards. There are certain places along the coast that's predicted 10 to 20 inches of rain. Can you even imagine 20 inches of rain? Because I can't. That's like a... You know, kind of like a little part of me is like, I've never been in a hurricane. But then again, I do have kids. I should probably be responsible.
Just stay inside.
Never. See, the thing is, we have a place right on the beach, and it's like a cottage. It's not like a major hotel. Like, I would be afraid to stay right there. For my life, afraid. I'm kind of afraid. I was like, YOLO. What?
Like crazy when we got hit by them, and then there was a bunch of seaweed in the ocean.
When was that?
It was like about 4 weeks before summer ended, summer break.
Oh, like in July or something?
Yeah.
Oh, that's terrible. I did go to Florida in June, though, so I guess I shouldn't be so upset. And we are getting our money back for most of it, so I shouldn't be so upset. But I am. Because now what do I do? What do I do in Ohio now?
Stay on the couch and watch Netflix.
Yeah, I do that anyway. That's kind of boring now.
Go to the museum.
You know, I was thinking about driving up to Kosai.
Go to the aquarium.
Oh,
It'll be the
fun.
same thing. I love the aquarium.
I've been.
This
So
is
it's,
fun. There's this thing where you can complete a circuit and it shocks you.
oh, yeah?
Yeah.
So I won't do that.
I wanna get
That sounds fun. No, I was thinking about, because I have my children, so I want to do something fun and memorable. So I was thinking maybe Kosai or the Indianapolis Children's Museum.
I was about to say,
Yeah.
you could take them there because they have like, they took out the part, the one that had the stand.
Oh, you're still recording.
But there was.
It's paused. Oh, it's not paused. No, it is paused. It's paused. I just need to stop it.